Number 4 method for the methods of preparation from alkynes. This is one of the important reaction. So I considered ethyne molecule, one example of alkyne. When you apply water in presence of H2SO4 and mercurious sulfate HgSO4, then in presence of acid, water produce H plus ion and OH minus ion like this. H plus will join with one carbon, OH minus will join with another carbon, triple bond is converted to double bond. Ultimately we will get the compound like this. So you will get one in an all functional group. But you should know one thing, when a compound contains both in and all, then the compound is unstable, it undergo rearrangement and it will convert to like this CH3 CHO, which is said to be ethanol. I mean CH3 CHO. How this rearrangement takes place? Let's see here. So this is one compound which contains both double bond and OH, I mean in and all. When it contains both in and all togetherly, then the compound is unstable. That's why some rearrangement takes place. This bond will shift from this to this. Hydrogen is removed as H plus. I mean here you will get double bond. Then this double bond will break and electron will come in this carbon. Then what happened? This C become negatively charged by taking 2 electron. This is CH2, single bond is converted, double bond is converted to single bond, and this becomes double bond O. Since H plus is released from oxygen, that H plus combined with this negative one, so it goes to CH3 and the compound become neutral. Ultimately you will get CH3, CHO, you will get the aldehyde. So from alkyne you can prepare aldehyde like this way. Similarly, this is called, this compound contain in and all functional group, and this is converted to keto group or aldehyde group. This is one of the isomer which is called tautomer. This is also called tautomerism. So tautomerism takes place in this type of compound. This is one of the alkyne which is called propane, unsymmetrical alkyne. When you apply water like this way in presence of sulfuric acid and H2SO4, HgSO4, sulfuric acid and mercurious sulfate, then here also it produces H plus and OH minus, but since it is unsymmetrical, Markovnikov rule you have to apply. Negative is added to that triple bonded carbon which contain less number of hydrogen. So OH will be joined with here, hydrogen will be joined with this carbon. So that is why you will get this one, double bond CH2. OH is joined with this carbon, hydrogen is joined with this carbon, triple bond is converted to double bond. Again you have got double bond and OH togetherly, so this is also unstable. Tautomerization takes place, then it will convert it to CH3 C double bond O CH3, which is acetone or propanone. So you may get aldehyde or you may get ketone based on your alkyne. So this is number 4 method. Now number 5 method, by Rosamund reduction. This is one of the important reaction. The methods of preparation, whatever we have done, from all the method you can prepare either aldehyde or ketone depending on the reactant. But this is one of the method, Rosamund reduction. By using this method you can prepare only aldehyde, you cannot prepare ketone. So that is why in exam you may get the question like this, give a method of preparation by which you can prepare only aldehyde. Then you have to write this reaction, and that's why in bracket I have written only for aldehyde. only for aldehyde. By using this method, you cannot prepare ketone. So this is one of the compound called acid chloride, because you know RCOOH, this is called carboxylic acid. When the OH is replaced by chlorine, then the compound is called acid derivative. I mean, this is coming from the acid, that's why it is called acid chloride. When you do reduction means addition of hydrogen in presence of one specific reducing agent, palladium and barium sulfate, and this catalyst is called Lindlar catalyst. Then you know reduction means addition of hydrogen, removal of electronegative element, that is called reduction. So here the electronegative element chlorine is present, so chlorine will remove from it and hydrogen will be added here. That means you will get RC double bond O, chlorine is removed by hydrogen, and the side product you will get HCl. I mean, you will get the corresponding aldehyde. For example, if you take this one, which is called ethanoyl chloride, IPSC name, ethanoyl chloride, when you do reduction in presence of the Lindlar catalyst, palladium and barium sulfate, then chlorine will be replaced by hydrogen, side product HCl, which is said to be ethanol. So any aldehyde, whether you want to prepare methanol, ethanol, propanol, butanol, any aldehyde you can prepare by applying Rosamund reduction. It depends on the reactant. What reactant you are considering, based on that you will get the product. If you take 3 carbon here, you will get propanol. If you take 4 carbon here, you will get butanol. Like that, any aldehyde you can prepare. So this is number 5 method. Now number 6 method, by ozonolysis of alkenes. Ozonolysis of alkenes. This is number 6 method, and this reaction you have got in class 11 when you have studied alkene. What about this reaction? Let us consider this alkene. Any alkene you can take. Reaction is called ozonolysis because you have to apply ozone. When you add ozone at the position of double bond, all the 3 oxygen atom will join and they will form a cyclic compound like this, CH, and this is CH2. Here double bond is present, double bond will be vanished, and at the position of double bond, the 3 oxygen of ozone join like this, and which is called ozonide. After formation of this ozonide, it is unstable. When you apply zinc water and some amount of heat, the ring will break like this. It will break like this. This part will come out, this part will go, and this oxygen combined with zinc, it produces side product zinc oxide. Now what about this? Here when you break, this single bond will be converted to double bond. This single bond will be converted to double bond. Ultimately the product you will get RCHO, which is one of the aldehyde, and here 2 hydrogen na, that 2 hydrogen you can write like this, HCHO. I mean, this is 2 aldehyde you have got, and the side product zinc oxide. If I take one example, let us consider this example. Suppose this is your alkene. This is your alkene. When you apply ozone, the same mechanism, CH3, CH3, this carbon contain 2 CH3, here double bond, this carbon contain 1 hydrogen and 1 CH3, and at the position of double bond, 3 oxygen atom will join like this. When you apply zinc water, this part will break like this part will break like this. Single bond is converted to double bond. Ultimately you will get CH3, C double bond or CH3, one ketone you will get, and this one you will get CH3, CHO, and side product zinc oxide. So these are the methods of preparation of aldehyde and ketone. In exam, maximum question you will get from aldehyde and ketone, because aldehyde and ketone shows maximum number of reaction methods of preparation, its chemical reactions, all are very important. So that's why you try to learn all the reactions. Thank you.